We're not going to cover addition polymers, which were part of the Level 2 curriculum. There is still an expectation that you know what addition polymers are. So when you've got unsaturated hydrocarbons and you add them together, so such things as PVC, PVA, those sorts of plastics and so on are made by adding lots and lots of alkenes usually together, and the double bond breaks, which makes them join together as a very big carbon chain. This is different. This is where we're taking some molecules and we're doing a condensation reaction. So what is condensation? Condensation is when I start with two either the same or different molecules. When they react, they join to make one new organic molecule. But in doing so, they lose a very small molecule, whether that is HCl or H2O. And it depends on what the monomers are as to which they'll lose. So that's why it's called condensation. You're taking two things and making it one, and you're losing a small molecule that is like water. So HCl is considered to be quite similar to water in this case, in organic chemistry. The two types we meet are polyesters and polyamides. So that the second half of those names suggests to you what type of reaction it is specifically. You have an esterification reaction, so making an ester bond for polyesters, and when we get to it, polyamides make an amide bond, and that's what holds the polymer together. What it means is it's being held together by a bond that can be easily broken by a process called hydrolysis. So what skills do you need? If I give you the structure of the monomer or monomers, it's normally two different monomers. You need to be able to draw a section of it like I've shown here. In that section, you need to be able to identify the repeating unit, so where it starts repeating itself. And there's some little tricks for that I'm going to show you soon. If I start with the polymer, you still need to be able to identify the repeating unit, but from that you need to be able to identify the monomers, what chemicals were used to make it. You also need to be able to identify what would be made if I did spill acid or base on this, because both acids and bases in solution will hydrolyze polyesters. So those are the skills that you need, or the knowledge you need. Right, let's go through it. I'm going to go through that. I've been given a section of a polymer. I think this one here is called Terylene, which is a type of plastic, basically. Okay. So Terylene is made from two monomers. To identify the repeating unit, the first thing I should do is identify it as a polyester. So I look for all of the ester links, and an ester link is a carbon chain, then COO, then a carbon chain, then COO, then a carbon chain. So that's what I'm looking for. I can see a COO with a carbon chain each side here, COO with a carbon chain each side here, and so on. So what I do is I normally get a pen or a pencil and I circle those ester links. Then what I do is I go along until I start seeing the same thing happen again. So at the moment, everything is different until I get to here, when I notice that it starts looking like this again. I can see that this bit and this bit are the same. So it started to repeat itself. So what I do is I put a square bracket through the ester link there and through the ester link there to show the repeating unit. The little n means that there are millions and millions and millions of these. It's a very, very big number. So you'll notice that actually there's a little trick. If I identify my ester links, it's between the first one and the third one as my repeating unit. So if I look for the first ester link, skip the next one, and then cut the second one in half, I've actually got my repeating unit. So there's your little trick. There's your first little trick. Find three ester links in a row, cut the first one and the third one in half, and you've got your repeating unit. Put the little n next to it to say that there are millions of these. Right, tick, we've identified the repeating unit. Now we need to identify the monomers from that. So what I've done here is I've drawn or rewritten just this in black down here. And I've taken the other ester link and I've broken it in half. And where the red arrow goes, I've just copied down O, CH22, O. That's all. With the blue, I've just written down this bit. Now I know that this molecule is made by a condensation reaction. Well, my brain automatically says that condensation has something to do with water, because that's what my brain's always thought condensation has something to do with. It's when you breathe on the window and you see all that steam. We incorrectly got to call that condensation. So that's what my brain has always thought it is. So I'm going to put some water into it. So the easiest way for me to do it is make molecules that I recognise is put H and OH. So on the left hand side, an H there to make an alcohol, and an OH there to make a carboxylic acid. And likewise here, an OH here to make a carboxylic acid, and an H here to make an alcohol. So what we find is that our monomer number 1 in this case is what we call a dicarboxylic acid. Di for 2, carboxylic acid. Now it could be a diacyl chloride. These could be Cl instead of OH. So when I said it could be HCl instead of H2O. Alright? And over here we've got what's called a diol. So a dialcohol, if you want to the full name, but a diol. So we make polyesters from a dicarboxylic acid and a diol. Alternatively, you could make it from a single monomer. What two functional groups would that single monomer have to have in it? If it was just one monomer, not two. This is a diol, this is a dicarboxylic acid. So what are the two functional groups we need if we had one monomer? It'd have to have two functional groups in it.
Is it the
Has to have an alcohol, definitely has to have an alcohol.
And aldehyde?
Not an aldehyde, you're close though. You've got an OH, I like that. Let's just go, I'm not going to make a big one. For that to react with itself to make an ester, what needs to be on this side to make that ester bond? Carboxylic acid or acyl chloride. So you could have a single monomer like this. 3-hydroxy propanoic acid in this case. That would actually make, under the right conditions, that would actually make a polymer. Alright? Harder to identify, we tend not to do ones from a single monomer. Can you get rid of that one? Alright? Now, polyesters can be hydrolyzed, broken with water as well. And it doesn't necessarily make the two monomers when we do it. If I hydrolyze it with an acid, it does. It makes both of these. Because alcohols are neutral. And dicarboxylic acids are, as the name suggests, acids. So if I hydrolyze under acidic conditions, an acid will be made, as well as the neutral thing. But I can also hydrolyze them using, for example, oven cleaner, which is sodium hydroxide. I can use something, a very strong base. Now a very strong base is not H2O, it's OH minus. So which hydrogen, that one or that one, do you think would be left off? So the carboxylic acid one or the alcohol one? Which one do you think we left off if we've only got OHs, not H2O? Good, the one on the left. So rather than being a carboxylic acid, it'll be what we call a carboxylate ion, a dicarboxylate ion. So it'll be O negative and O negative. Alright? So you'll still get the alcohol being made, but now you'll get the carboxylate ion. So that's a very important difference, and often in exam questions they'll ask for you to compare and contrast the products of acid and alkaline hydrolysis. The alcohol will be exactly the same, but under alkaline conditions you can't have the carboxylic acid, it will be the carboxylate ion. So COO minus on each side instead. Alright, so could we draw a section if we had the monomers? We will need to have a look at that in a moment. So that's going to be our little activity we're going to do in a moment. Can we identify a repeating unit? Yes, so long as we know to identify the ester links. And how many do we need to look for? 3, good. And it's the first and the third we cut in half. Can we identify the monomers? Well, we pull that repeating unit out, break it in half, and add what molecule?
H2O.
Water, well done. And then we also need to know about the hydrolysis, comparing and contrasting those. It makes the monomers, in this case. By the way, when we do polyamides, it won't. Okay, it's a bit different. But it will make monomer 1 and monomer 2 under acid conditions, but under alkaline conditions it'll be slightly different. And that's what we need to know about polyesters. All right, any questions before I turn that off?